Hello and welcome to a Level 3 Cambridge Technical and Engineering revision session for Unit 3 Principles of Mechanical Engineering. And this video is going to deal with question 4. It's going to come in two parts. I'm going to do question 4a, which has two components, and then we'll look at question 4b in a separate video. Right, we have here a question which deals with a small crane lifting a load of 2,000 newtons with a jib, that's this bit here, of length 3.5 meters, inclined at an angle of 30 degrees. It says, calculate the components of the load which act parallel to and perpendicular to the jib of the crane. So parallel would be in that direction, if you will. Something along those lines. And perpendicular would be at 90 degrees to the jib. That would be in that direction. Okay, so to help me out here, I'm going to just use this space to draw a free body diagram. I'm going to use that to illustrate how you solve this particular problem. So we have our parallel. So let's just draw in our jib. Scale isn't important in this situation. Don't need to be worrying about scale, it's just a case of having the lines to illustrate the load. I'll just pop that on here for a second. It's going in that direction. So that's my parallel component, and then I'm going to pick up, and there's my perpendicular. That's at 90 degrees. That way. Now, that we know is 2,000 newtons. And if you look, this parallel and this perpendicular, because we know that that's perpendicular to 90 degrees, it's created for us a new right angle triangle. With the hypotenuse being the force, we know that this angle will be 30 degrees. We've now got an opposite to this force at this angle, and we've got an adjacent. So we can calculate the resulting parallel force and the resulting perpendicular force by using sine and cosine. So let's have a look at that then. Our parallel component we deal with first is going to be our 2,000 newtons multiplied by, it's our opposite, parallel, the sine of 30 degrees, which will equal, and if you know your trigonomic identities, the sine of 30 is 0.5 or a half, so that's going to be 1,000 newtons. Now we'll here, perpendicular, we have our cosine. And cosine of 30, because I know my identities, I can tell you that that's going to be 0.866 on the calculator. But just to prove a point, cosine of 30 equals 0.866, and just check that sine of 30 is half, or 0.5. Okay, so 0.866 times 2,000 newtons equals 1732. So the parallel is 1,000 newtons and the perpendicular is 1732 newtons. And that brings us to the part 2 of the question. Using your answer from part A, calculate the moment at the pivot of the crane. So that we're looking now for the moment of force, it's a turning force, okay, on the pivot of the crane. So we're looking for the force acting at this point here at the end of the crane. Well, the crane's at 30 degrees, and the perpendicular then would be the force acting in that direction, and we know that that force acting in that direction is 1732. So we've got 1732 newtons acting over 3.5 metres. So 1732 multiplied by 3.5, just have to have left that on my calculator, times 3.5 equals 6062 Newton meters. Hope that's been helpful and clarified a few points with regards to parallel and perpendicular, and I hope you do well in the exam.